Hello everyone, welcome back to my channel. Today we would be solving the questions of Chemistry HL Paper 1 of the November 2021 attempt. So yeah, this is the previous IB paper. So anyone who would be attending the May 2022 paper, this is really important for them. So without wasting for the time, let's start with the question. So our first question goes like this: question is how much ethanol contains 1.2 10 to the power 24 atoms of carbon. Now ethanol has a molecular formula of C2H6O. That means that every molecule of ethanol contains 2 atoms of carbon. So one atom of carbon, we can think like this. So one atom of carbon will be there in half of a molecule, right? So the number of molecules of ethanol would be the total atoms of carbon divided by 2. So it would be 0.6 times 10 to the power 24. Now moles of ethanol would be number of particles or number of molecules divided by the Avogadro number. So it's 6.10 to the power 23. There's the number of molecules of ethanol divided by the Avogadro number, 6.02. So if you cancel this 10 to the power 23, we get 6 by 6.02, which is approximately equal to 1. It's a little lesser than 1, but we get approximately to 1. So for the question 1, option C is the correct answer. For question 2, we have 3 moles of C3H8 mixed with 20 moles of O2. Which quantity is present at the end of the reaction? So here we need to find out the excess reagent, and so here let's try to find the limiting reagent first, because we know the moles of both the reactants, so it's very easy to find the limiting reagent. What we used to do, we used to find the N by SC, and it's the moles. SC is the stoichiometric coefficient. For C3H8, moles is 3, stoichiometric coefficient is 1, so N by SC ratio is 3. For O2, moles is 20, stoichiometric coefficient is 5, so 20 by 5 it becomes 4. So the reactant which has the lesser amount of, the reactant whose N by SC ratio is less, that is your limiting reagent. So in this case, obviously this is lesser. N by SC of C3H8 is 3, it is lesser than that of O2, which is 4. So C3H8 is the limiting reagent. So what we know is at the end of the reaction, there would be no C3H8. So option A would be an incorrect answer. Now let's see how much oxygen will be left after the reaction. So moles of O2 reacted. This is actually reacted by moles of CH3 reacted. This would be 5 by 1. There's a stoichiometric ratio thing. So moles of O2, and this is 5 because the stoichiometric coefficient of O2 is 5. This is 1 because stoichiometric coefficient of C3H8 is 1. So just putting in the moles here, we get moles of O2 that is reacted is 15. So moles of O2 that will be left is 20 minus 15, that is 5. So this becomes the correct answer. Now see, as CO2 and H2 are produced at the product side, so obviously at the end of the reaction, CO2 and H2 would be present. But let's just check the number of moles. So moles of CO2 by moles of C3H8, this will be equal to 3 by 1. So from here, moles of CO2, if you calculate, it would be 3 times, this is 3. So 3 times 3, it should be 9. But here it's given 12, so this is incorrect. Let's do it for H2O2. So NH2O by 3, I'm just directly skipping the step, it will be 4. So N of H2, that is moles of H2 should be 12, but it's given 16. So this is also incorrect. Option B is the correct answer. Now in the next question, we have 2 containers that are connected by a valve. So what is the total pressure after the valve is open, and 2 gas samples are allowed to mix at constant temperature? So what happens is, the number of moles of the gas, that will remain constant. Okay, that will remain constant throughout. Like in any case, even if the temperature was changing, we can obviously say that the number of moles of gas will be constant. So what happens is, let's find out initially how much moles was present in container 1 and 2, and after opening, we can just equate this sum of N1 plus N2 with the total moles, because obviously after opening the gas molecules, they will add up together. So N1 would be P1 V1 by RT1. This is like from PV equals NRT. And N2 would be P2 V2 by RT. This is container 1, that's why P1 V1 I've used the subscript. This is container 2, that is PV, that's why I've used P2 V2. And temperature I have taken T in both cases because the question is given as constant temperature. So after opening, we have P total V total by RT equals P1 V1 by RT plus P2 V2 by RT. So after cancellation and everything, you get P1 V1 plus P2 V2 by V total. Now I know P1 is this, V1 is this. I know P2 is this, V2 is this. But what is V total? V total is the sum of the volumes of 2 containers. This is 4 plus 2, that is 6. So upon solving, we get P total as 2.3 times 10 to the power 5, which is basically option B, and which is the correct answer to this question. Moving on to question 4, which species has 2 more neutrons than electrons? This is pretty much a simple question. So firstly, we need to find the number of neutrons. How do you find the number of neutrons? You subtract the atomic number from the mass number. So you get 6 minus 3, that is 3. So lithium plus has 3 neutrons. Be2 plus has 9 minus 4, 5 neutrons. Na plus has 23 minus 11, 12 neutrons. And calcium has 42 minus 20, that is 22 neutrons. How do you find the electrons? Now, here, all of them has positive charges. So for positive charges, how we generally find the electrons in this way, that the positive charge is created by the deficiency of an electron. Okay, so Li plus, this means that let's say we have total of 3 protons for Li. Positive charge means there is 1 electron less as compared to the protons. So that's why there is a positive charge. So number of electrons is 3 minus 1, that is 2. So in this case, charge is plus 2. So number of electrons would be 4 minus 2, 2. So 2 electrons are deficient, that's why there is a plus 2 charge. For Na plus electrons is 11 minus 1, that is 10. And similarly for Ca2 plus electrons is 20 minus 2, that is 18. Now we have to check in which case the difference between neutrons and electrons is 2. In this case, the difference is 1. In this case, the difference is 3. In this case, the difference is 2, and that is the correct answer. Here also the difference is 4. Obviously, option C is the correct answer to this question, where neutrons is 12, electrons is 2. So there are 2 more neutrons as compared to electrons here. Moving on to question number 5, the question goes like this: which statement explains why the second ionization energy of aluminium is higher than the first ionization energy of magnesium? Now, in any sort of ionization energy question, we always need to approach the question by the electronic configuration. Second ionization energy of aluminium is basically the ionization of Al plus ion, and the first ionization energy of magnesium is basically the ionization of Mg. So, writing the configuration of Al plus and Mg, you will find that in both the cases the configuration is 1:2, 2:2, 2:6, and 3:2. So, yeah, both of them have the same number of electrons. But what happens is in aluminium, there is one extra proton because the atomic number of aluminium is one greater than that of magnesium. So what happens? The number of electrons is same, but the nuclear force of aluminium would be greater. As a result, what happens is the ionization energy would be more in the case of aluminium, because obviously as the nuclear force is higher, you would have to apply some extra force to remove the electron from the orbit of aluminium. That's it for question 5. So option D is the correct answer to this question. Both have the same number of electrons and aluminium has one proton. In question 6, we have to find out which ion has the largest radius. Now, firstly, we need to check if all these ions, all these elements are in the same period or not. So we have sodium, magnesium, potassium, phosphorus, and sulfur. So they are all in the same period, so that's okay. Now, what happens is whenever you have positive ions, just remember positive ions are always smaller than that of the respective atoms, because what happens when you are pulling out electrons, the nuclear charge doesn't increase, and what happens, the electron-electron repulsion, this decreases, which results in a decrease in the atomic radii. So yeah, Na plus and Mg2 plus, they won't be the answers. But what happens for anions? As you have more electrons than protons, the electron-electron repulsions will come into place, and as a result, the orbit or the size of the final orbit would increase. Now, we need to check when we have two anions. What we need to check is we need to check the total number of electrons in its outermost orbit, and we need to check the atomic number or the number of protons. So for phosphorus, number of protons is 15 and the electrons is 18. For sulfur, atomic number is 16 or number of protons is 16 and the electrons is 18. Now, in the second case, the atomic number is more. As a result, what happens is the nucleus will try to pull the electrons towards itself with a greater force. As a result, the atomic radii or the ionic radii in this case will decrease. But for phosphorus, you have lesser protons. So what happens is the nuclear force won't be that strong and the ionic radii will be more. So option C is the correct answer to question 6. Next is which combination describes acid-base nature of aluminium and phosphorus. Now this is pretty simple. So phosphorus is a nonmetal. So nonmetals produce acidic oxides. And for aluminium, the most common oxide of aluminium is Al2O3. And as we have studied, Al2O3 is always an amphoteric oxide. So option A would be a correct answer. Now there's another way of approaching this. If we just know that phosphorus oxides will produce acidic substances like H3PO4, etc., etc. From this list, we can just choose this, and option A would be the correct answer, even if you somehow mess up the aluminium. But it's really easy. Aluminium always produces amphoteric oxides. Now, then the next question, we have to find out which complex ion contains a central ion with oxidation state of +3. We would be applying our general formula to calculate the oxidation state. What happens is here Pt is your central atom. So let's assume that the oxidation state of Pt is X. Oxidation state of chlorine is always -1. We have 6 chlorine, so 6 of -1. This will be equal to the total charge. Total charge is -2. From here, we can figure out the oxidation state of platinum, which comes out as +4. In the next case, we have Cu, H2O whole 4, and OH whole twice. We don't know the oxidation state of Cu, and Cu is the central atom. So let's assume that the oxidation state of Cu is X. Oxidation state for water is always 0, so 4 times 0. And oxidation state for OH is -1, like general OH minus. So it would be 2 times -1. So solving this, we get X as +2. So this is also not the correct answer. We need oxidation state of +3. Next one is NiNH3 whole 4, H2O whole twice. Now NH3 and H2O, both of them have oxidation state 0. And Ni is the central atom. We don't know the oxidation state of Ni. So again, let's assume Ni as X. NH3, H2O will be 0, and the net oxidation state will be equal to +2, which is the charge here. Upon solving, we get X as 2, which is again not equal to +3. Now only the last option is left. So let's check it. Here, cobalt is our central ion. NH3 is obviously 0 and Cl is -1. So X plus 4 times 0, oxidation state of NH3 will be 0. And 2 times -1 for chlorine. That will be equal to +1, because +1 is the charge on this complex. Upon solving, we get X as +3. And yeah, in option D, our oxidation state of cobalt is equal to +3. That is the correct answer to this question. Now in question 9, which combination would create the strongest ionic bond? Now we have the combinations like this: ionic radius large, charge on ion side. Now how to solve this question? We just need to know that ionic bond is actually nothing other than electrostatic force of attraction between two ions, two oppositely charged ions. Now, from the electrostatic force of attraction, we know that this force, electrostatic force of attraction, is directly proportional to the product of the charge on the ions, and it's inversely proportional to the square of the distance between the two ions. So, as it is directly proportional to the product of charge, obviously greater charge means stronger bond. So, for charges on ions, higher the charge, stronger will be the ionic bond. That's the first point. Second one is it's inversely proportional to the distance between two ions. So, if you have smaller ions, what happens is the distance between the two ions will decrease. So, that's why if you have smaller radii, you will have a stronger bond. So, obviously, from the options, option C is the correct answer. You need a smaller ionic radii, but you need high charges on the ions for the strongest ionic bond. Coming to question number 10. Which compounds contains both ionic and covalent bonds? From the options, it's quite evident. A is the answer. In A, you have CH3CO, Na, which can be drawn like this. CH bonds are all covalent bonds. Here's a C double bond, which is again a covalent bond. CO minus, it's again covalent, but the bond between O minus and Na plus, this is an ionic bond. So you see both covalent and ionic bonds are present in this compound. So option A is the correct answer. But you can also check for the other option, CH3COOH. This thing looks like this. All of the bonds would be like covalent bonds. Sometimes people might get confused that CH3COOH also ionizes in water because it's a weak acid. But yeah, it's a weak acid, so most of it won't be ionized. So we can just assume this as a covalent bond. K2O is obviously it's an ionic compound. It's made up of 2 K plus ions and 1 O2 minus ions. Same for CaCl2, it's made up of 1 Ca2 plus and 2 Cl minus ions. So again, option A is the correct answer to this question. Moving on to question 11. We have to, following compounds have relative molecular mass, what is the order of increasing boiling point? Now to solve any questions related to boiling points or melting points, we have to check the intermolecular forces of attraction. In this case, we have OH, mostly we have OH, and we know if you have a hydrogen attached to an oxygen, there will be hydrogen bonds. So in this question, we have to check the magnitude of hydrogen bonding, and that will give us the answer. Now, magnitude of hydrogen bonding goes like this. Carboxylic acids will give you the highest magnitude of hydrogen bonding. Then will be alcohols and then aldehydes and ketones. So from this magnitude chart, obviously option B is the correct answer. Let's move on to question 12. So in this question, we have to find out which molecules contains 2 pi bonds. Now to solve this question, we need to know one thing, that if you have a single bond, it means 1 sigma bond. If you have a double bond, it means 1 sigma bond and 1 double bond. So 2 bonds of the double bond is one of them is sigma, one of them is pi. And if you have a triple bond, one of them will be sigma and 2 of them will be pi. Now we just have to draw the diagrams, or we have to write out the structures, like write out the bonds and then calculate how many pi bonds are there. For example, in the first one, we have HCN. There's a triple bond between C and nitrogen. Triple bond means what happens? You have 2 pi bonds. So yeah, this is correct. And we have one single bond. One single bond means 1 sigma, and there would also be another sigma bond here in this triple bond. So 2 sigma, 2 pi. Next one is H2CO3. It looks like this. So here obviously there are 4 single bonds and 1 double bonds. So there are a total of 5 sigma and 1 pi bond. Obviously 2 is not the correct answer because we need 2 pi bonds. Lastly, we have H2C2O4, which looks like this. And in H2C2O4, again, we have 5 single bonds and 2 double bonds. 5 single bonds means 5 sigma and 2 double bonds means 2 sigma and 2 pi. So total of 7 sigma and 2 pi. And yeah, it also contains 2 pi bonds. So this is also correct. So 1 and 3, option B would be the correct answer. Now we are heading on to question number 13. What is the hybridization of nitrogen, chlorine, and in NCl3? We just have to draw the structure and then find the total number of electron pairs around each of nitrogen and chlorine. Now around nitrogen, we can see there are 3 bond pairs and 1 lone pair. So 3 bond pair, 1 lone pair, so total of 4 electron pairs around nitrogen. If you have 4 electron pairs, so your hybridization would be sp3. 1 electron pair for S and 3 electron pairs for P. Similarly for chlorine, if you check, we have 3 lone pairs and 1 bond pair. So again, 3 lone pair, 1 bond pair, total of 4 electron pair. So hybridization becomes sp3, 1 electron pair for S and 3 for P. So yeah, option D is the correct answer with both sp3. Now in question 14, we have to analyze which combustion reaction releases the least energy per mole of C3H3. And they have given you a list of bond enthalpies. Now to solve this question, we need to identify which bonds are broken and which bonds are formed in these reactions. Now what happens is, just check C3H8 is common in all the options. So we don't need to analyze for C3H8. Because the total number of bonds broken for C3H8 will be same for all the compounds. Similarly, H2O. See, 4H2O is formed in all of the options. So we don't need to check which bonds are formed for 4H2O because it will be same for all the options. We can just work on O2, CO2 and CO and we can get our answer. Let's check what happens. In the first option, 5 O double bond O bonds are broken. And 6 C double bond O are formed because CO2 is like this. So we have 3 moles of CO2 to a total of 6 CO bonds. Now in the second one, 9/2 O double bond O bonds are broken. 4 CO bonds are formed and 1 C triple bond O is formed because carbon monoxide is like this. And one of them is a coordinate bond. I drew the direction wrongly. Yeah. Same for option C. 4 double bond O were broken. 2 C double bond O formed and 2 C triple bond O are formed. Option D again, 7 O double bond O broken. 3 C triple bond O formed. Now we have to just do the formulation now. Now to break bonds, we have to apply energy and bond formation releases energy. So breaking of bonds, the energy would be positive and forming of bonds, the energy would be negative. In the first case, 5 O double bond O were broken. So 5 times 500, this much amount of energy was required. And how much energy was released? 6 of C double bond O. So 6 times 800, this much energy was released. So total of 2300. The enthalpy comes out as minus 2300. So total of 2300 kilojoules of energy was released. In the next part, we have to do the same thing. So 9/2 moles of O double bond O were broken. So energy that has to be applied is 9/2 times 500. And how much energy would be released? So we have 4 C double bond O and 1 C triple bond O. So 4 times 800, 1 times 1000. This is 800, this is 1000. Coming out as minus 1950. In the next one again, 4 O double bond O, 2 CO and 2 C triple bond O. So 4 times 500 minus 2 times 800 minus 2 times 100, resulting in minus 1600. In H4, you have 7/2 times 500 and you have 3 C triple bond O. So it becomes minus 3 times 1000. On summing, it becomes minus 1250. So we need to know which combustion reaction releases least energy. So we need to know which one has the least negative value. So you can say which one releases the least amount of energy. Okay, so for that, obviously, this one releases the least amount of energy because negative of 1250 means it is releasing 1250 joules of energy. Negative of 2300 means it is releasing 2000 joules kilojoules of energy in this case. So yeah, this is obviously the lowest value of energy that is being released. So option D is the correct answer to this question. Now, question 15 again, it's a pretty easy question. Which equation represents the standard enthalpy of formation of lithium oxide? For this, just know for any standard enthalpy of formation question, 1 mole of product needs to be formed and the reactant should be in the standard state. So in this case, only here 1 mole of product is formed and O2 and Li are there in the standard state. O2 is standard in general a gas and lithium is in general a solid. And B is the correct answer to this question. Moving on to option C, we have this Born-Haber cycle, and we need to find out the lattice enthalpy of sodium oxide. So lattice enthalpy is basically this line. So we have to move all the way from here to the top. The energy that we would require in this part, that will be equal to the lattice enthalpy. Now in the first step, see, we are going here to here. Now see, from if we want to form Na2 from sodium and half O2, this much energy must be, this much energy will be released. So to convert Na2O to two sodium atoms and half mole O2 gas, what happens is we have to apply this much amount of energy. So it will become plus, so it will become minus of minus 414. It will be like plus 414. In the next one, it will go just the same. So we are applying energy here, we are applying energy here, then here, and also here. Okay, in this case, what happens? We are going from here to here to here. You can say we are following this path. So yeah, in this one, we have to, we would be losing energy. Here, it's a gain of energy again. If you sum this up, you will get the first option as the answer. Now in question 17, which of the following situations is the forward reaction is spontaneous? So whenever you have a forward reaction, you would always, you'll always see that the value of Kc is greater than 1. This means that there are more products at equilibrium as compared to the reactant. So from this, directly option A would be the answer, but we can analyze the other options too. Cell potential is negative. If cell potential is negative, what happens is your delta G becomes positive. Because see, delta G is minus NFE. If E is positive, so this entire term delta G becomes NFE, which is greater than 0. Now if delta G is greater than 0, obviously your reaction is non-spontaneous. So option B is not the correct answer. Gibbs free energy of the reverse reaction is negative. No, this is also not correct because the Gibbs free energy of the reverse reaction is negative. So the Gibbs free energy of the forward reaction would be positive. So in that case, if delta G becomes greater than 0, then obviously our reaction is non-spontaneous. C is also not the correct answer. Entropy change of the universe for forward reaction is negative. This is also not the correct answer because if the entropy change for any reaction becomes negative, there is a high chance that the reaction is non-spontaneous. So option D is not the correct answer too. So yeah, we can just conclude that option A is the correct answer. Now in question 18, which instrument would best monitor the rate of this reaction? We have twice Ki plus Cl2 gives you twice KCl plus I2. Now see, in a chemical reaction, mass is conserved. So the total mass of the reaction will never change. So using a balance, it will never work. Now no gas is produced here. The gas syringe is also useless. Now total volume of this reaction will also not change. If we consider the liquid volume, it will also not change. It will also be the same. This will also not work. But colorimeter will work because the color of this, because there would be a color change in this reaction because of this I2. What happens is the color will change to brown because of the formation of I2. So if I2 is, as I2 is being formed, this, the color of the solution will slowly start turning to brown. So using a colorimeter, we can see, we can find out the rate of change of this color. And then obviously we can derive a rate for this reaction. Option B is the correct answer to question 18. Question 19, which combination has the greatest rate of reaction at room temperature? So we have zinc and we have copper. We have zinc as 1 gram powder or a 1 gram strip. And we have copper as 550 centimeter cube of 0.2. This is more concentrated. And this is less concentrated. Now, first things first, obviously we know that if we are powdering something, the reaction rate will increase because powdering increases the surface area for reaction. So obviously these C and D, they will be wrong because we can't have strips and we have the greatest rate of reaction because surface area is low. As soon as we powder the zinc, the surface area increases as well as the rate. So yeah, either of A and B could be our answer. In A and B, this is concentrated, and this is this is more concentrated, this is less concentrated. Now, rate of reaction depends upon the concentration of the reactants. So if your reactant is more concentrated, the rate would be more. So of course, option A is the correct answer because zinc is powdered and CuSO4 is in a more concentrated state. Now, which graph shows the first order reaction? This is question 20. We have like two types of graph. In first graph, we have reactant concentration and time. In second graph, we have rate of reaction and reactant concentration. Now, rate and reactant concentration would be related by this equation for first order. Rate equals minus K times C. So if I just try to plot it, the graph would look something like this, where this would be the rate and this is the reactant concentration. But here you see this is kind of a parabolic and there's a constant. So option B, option D, these won't be correct. Now, if I want to consider the reactant concentration and time, it is a negative exponential equation. So there would be an exponential decay. See, there's a straight line. So obviously this can't be the answer. But here, option A, we can see it's an exponential decay. So the reactant concentration is decreasing exponentially with time from this equation. Yeah, A is the correct answer to this question. Now in question 21, there is a rate equation given, that is rate k of A times B. And we have to find out which mechanism is consistent with this rate equation. Now to solve this, we have to write the rate equation for the slow reactions, and then this inert has to be replaced with this A by the, this is a reversible reaction, so we can write the Kc. So yeah, we would be replacing the inert with the concentration of A. In the first option, what happens is we can write the rate of the slow reaction like this, R of K times B times I, B here, I here. And we also know that Kc is I by A square from the fast reversible reaction. So concentration of I is basically Kc times A square. I can replace it here, and maybe I can write it as a K dash, the new K. It will be B A square. So this is not the rate we are looking for, so this won't work. So, the first reaction won't work. Won't work. This mechanism is wrong. Let's try with the next one. We have the slow reaction. Let's try to write the rate of slow reaction is K times A times I. So here we have the, the fast reaction. So writing the Kc value, Kc is I by A times B. So concentration of I can be written as, this can be written as Kc AB. Now placing this value of I here, we get K, you can just make it a K dash, because this K and this K, it is a little different. But yeah, it would be a constant. So it would be A square times B. And again, it doesn't match with the rate, so this is also incorrect. Next one, E to I, this is slow, and I plus B to P. So writing the rate equation of the slow reaction, the slow pathway, it becomes R times Ka. Again, this is not correct because we need Kab. Now we have the last one where it goes like this. Let's write the mechanism for the slowest step, rate from the slowest step. It becomes R times K times A times I. Okay, so AI, and again, this I can be replaced as I by B. This is your Kc. So your I is Kc times B. You can replace I here, this will become a K dash, but here the rate equation tallies with the rate equation that is given in the question. So option D is the correct answer to this question. Coming to question 22. We have a reversible reaction of reaction quotient 4.5 and equilibrium constant Kc 6.2. Now, which statement describes this reaction? And you guys can read the option here, but let's just try. So Kc has a greater value than that of Q. If Kc has a greater value than that of Q, it means that the reaction is still going on the forward direction. So more and more products are being formed. The system hasn't reached equilibrium because at equilibrium point, your value of Q would be equal to Kc. But in this case, Q is not equal to Kc, so yeah, this is not the correct option. The second is the concentration of reactant is greater than that of product. No, this is not correct because QC and Kc, if your concentration of reactant should be greater than that of product, your QC or Kc value should be less than 1. But in both cases, it's greater than 1. Obviously, this won't work. In the last case, at equilibrium, concentration of reactant is greater than that of product. It will also not work because Kc should be less than 1 if you want more reactants than products. But here, Kc is obviously greater than 1. So this is also incorrect. Now coming to option B, which is the correct option. So as the reaction is in the forward direction, what happens is the rate of forward reaction is greater than that of the rate of the reverse reaction. And that is why your products are being formed, right? So yeah, option B is the correct answer to this question. Now question 23 again is a pretty simple question. We have a graph that shows the gives energy of a mixture of N2O4 and N2 at different proportion, which point shows that the system is in equilibrium. Remember the point at which there is the lowest value of gives free energy, that is the point where the system is at equilibrium. So yeah, option B, or point B is the point where the system is where system has the lowest value of gives free energy, and that is where the system is at equilibrium. Now moving to question 24. Which ions are present in an aqueous solution of Na2CO3? Again, this is pretty interesting. Na2CO3, if you put it in water, you will have Na2 plus ions and CO3 2 minus ions. So firstly, CO3 2 minus ions would be present. Now what happens, as CO3 2 minus is a salt of a weak acid. CO3 2 minus is formed from H2CO3. H2CO3 is a weak acid. So as H2CO3 is a weak acid, what happens is, or HCO3 minus is also a weak acid. So CO3 2 minus is a strong base, okay? Because if you have a weak acid, its conjugate base is going to be strong. So HCO3 minus is a weak acid. So its this conjugate base will be strong. So this is a strong base. So what happens if you put a strong base with water? What happens? It will extract the H plus ion from the water molecule and form HCO3 minus, and water will be left with OH minus. So we will have SCO3 minus and OH minus. These two ions will also be present. SCO3 minus, OH minus, CO3 2 minus. All these three ions will be present in the aqueous solution. So option D is the correct answer to this question. 25 again is pretty simple. We need to find the pH of 0.01 mole per dm cube KOH. So KOH is a strong base, so we can just assume that all of the KOH will be dissociated, and the concentration of OH minus ions would be equal to the concentration of KOH, and that is 0.01 or 10 to the power minus 2. First, let's find the POH. POH would be minus of log OH minus, that is minus of log 10 to the power minus 2, which becomes 2. So POH of KOH would be 2. So pH is 14 minus POH, so 14 minus 2, that is 12. So option C is the correct answer to this question. Moving on to question 26. What is the possible value of pH at equivalence point of titration of strong acid with a weak base? Yeah. What happens whenever you're titrating a strong acid weak base at equivalence point, you will never get the pH equal to 7. Okay, pH equal to 7 is only obtained on titration of a strong acid and a strong base. So yeah, 7 is not the answer. What exactly happens at the equivalence point then? Now, whenever you're, let's say, titrating a strong acid with a weak base or a weak acid with a strong base, just remember the strong, whichever part which is strong, that will guide the pH. In this case, we have a strong acid. So our pH will be less than 7 or towards the acidic side. If we had a strong base titration with a weak acid, the pH would have been greater than 7 or a basic solution would be formed at equivalence point. So yeah, option A is the correct answer because it is the only option where your pH of the solution is acidic at the end of the, at the equivalence point. You can also think like this: at equivalence, strong acid prevails and the solution is acidic. Now question 27, what is correct for pure water? Now this is a pretty interesting question. So pure hot water means you're increasing the temperature of water. Okay. Now, as you're increasing the temperature of water, the dissociation of water molecules will increase. Okay. So as you're increasing the temperature, obviously more bonds will break. So more of H plus and OH minus ions will be there in the solution. So your Kw value will change, or we can say that the Kw value will increase. Okay. So as the Kw value increases, the pH will be less than 7 because what happens is or we can say pKw is minus of log Kw. And we know H plus and OH minus concentrations would be the same because what happens when one H2 molecules, one of the H plus ions dissociate, you have one H plus and one OH minus. Similarly, whenever an H plus ion is generated, an OH minus ion will also be generated. So H plus and OH minus ion concentration will always be same. But as your Kw value changes, what happens is the pH, pH would be pKw by 2. As Kw value decreases, Kw value increases, the pKw value will decrease. So pKw by 2 will obviously come out less than 7. Option B would be the correct answer in this case. Question 28. What is the change of oxidation state of oxygen in this reaction? Again, pretty simple question. In H2O2, we are taught that OH is in the -1 state, but yeah, we can also find it. So hydrogen is in a +1 state, so 2 times +1. We don't know the oxidation state of oxygen, so let's assume it as X. And as it is neutral, the total charge will be equal to 0. Upon solution, we will get that X is equal to -1. And oxygen on the right hand side is only present in H2O. So in H2O, let the oxidation state of oxygen be Y. So 2 times 1 plus Y, this will be equal to 0. So Y becomes -2. So the change in oxidation number is final oxidation number minus initial oxidation number. So -2 minus of -1, so it's -1. Option C is the correct answer to this question. Moving on to question 29. We have this voltaic cell where your copper is more reactive than silver. So copper is more reactive than silver. This means that E0 value or the reduction potential of copper is greater than the reduction potential of silver. So if that is the case, then our copper will get reduced and silver will get oxidized. Copper getting reduced means Cu2 plus ions will get converted to Cu and Ag will get converted to Ag plus ions. Okay, so that's the information we got from the first option. So Ag getting converted to Ag plus and 2 electrons. This reactions generates electrons. So in this half, electrons will be generated. And Cu is using up electrons. So electrons get used up here. So basically electrons are formed at the Ag electrode and they move to the copper electrode. So flow of electrons is from Ag to copper. Any of option A or C might be correct. Now flow of negative ions in salt bridge. What happens is in the first case, or let's start with the second case. What happens is as time goes on, Ag plus ions start building up inside the solution. Now to neutralize this charge, what happens is negative ions from the salt bridge, I'm just using a random Cl minus sign. So negative charges from the salt bridge will come to the Ag to this side and to make the overall charge 0. So as Ag plus ions is produced, so there will be excess positive ions on the anode part. This is the anode, obviously this is the anode. And this is the cathode. In anode you will have oxidation, this is the oxidation reaction, cathode you will have reduction. So yeah, the negative ions from the salt bridge will move towards Ag. So flow of negative ions in salt bridge would be towards Ag. Option A is the correct answer to this question. Now in question 30, we need to find out which species will react together with each other to spontaneously under standard condition. So in this case, we just need to check in which reaction E0 value is positive, and that's the correct answer basically. Zn2 plus Pb gives you Zn plus Pb2 plus. The E0 value would be -0.76, negative of -0.13 from these two values. So it's -0.60. This will not be the case because E0 value is negative. In the second case, what happens is Pb2 plus Br2. Now, first thing, there would be no reaction in this case because in both of the cases, if there is a transfer of electron, it should be a redox reaction. One of the reactions should be getting oxidized, the other one should be getting reduced. But here, if you check the reaction, Pb2 plus will get converted to Pb, which is a reduction reaction. Br2 plus will get converted to Br minus, which is again a reduction reaction. Now, two reduction reactions cannot go simultaneously, so there would be no reaction for part B. Part C again, Zn2 Br minus. Now what happens is Zn will get converted to Zn2 plus, which is an oxidation reaction. Br minus will get converted to Br2, which is an oxidation reaction. Two oxidation reactions cannot go simultaneously in one direction. Okay, it should be one oxidation, one reduction. So again, there is no reaction possible for option C. Let's just check part D. So we have Pb and Br2. So what happens? Pb will get oxidized to Pb2 plus, and Br2 will get reduced to Br minus. So yeah, to find the E0 value, this Br minus is 1.09, which is getting which Br2 is getting reduced. So yeah, and Pb is getting oxidized. So we have to write minus of -0.13. So it's 1.22 volts. So E0 is positive only in option D, and option D is the correct answer to this question. Now moving on to question 31. Which aqueous solutions produce oxygen gas during electrolysis? We will have dilute CuCl2 with inert electrodes. We will have dilute FeSO4 with inert electrodes. We will have dilute CuCl2 with copper electrodes. Now, first things first, option 3 cannot be the answer, because if you have copper ions and copper electrons, what happens is copper is produced at cathode and Cu2 plus is produced at anode. So only copper is getting generated in this case. So oxygen cannot be generated in option 3. So option 3, obviously, we can just rule out option 3 and just check option 1 and 2. In option 1, in 1 and 2, in both the cases, Cu2 plus and Fe2 plus would compete at the anode with H plus. So this is not really important because this will generate the H plus ion. But at the cathode, you will have SO4 2 minus for SO4 and Cl minus for CuCl. Okay, and there would be H2. Now, we need to find which one will have the lesser E naught value. Now see, SO4 2 minus is not even given in this table. So we can say that SO4 2 minus will have a very high E naught value or something. So this we can just rule out SO4 2 minus. We have to check between Cl minus and H2O. So like between SO4 2 minus and H2O, obviously H2O will give the reaction and O2 will be formed. So yeah, option 2, this will be 100% correct. Now we have to check for option 1. Between Cl minus and H2O, check the E naught value. Cl minus is minus 1.36 and this is 1.23. We need just remember at the cathode, lesser E naught value. Like the component having the lesser E naught value will get produced. So yeah, obviously H2O, it has a lesser E naught value. So O2 will be formed. So yeah, option 2 and 3, both of them are correct answers. So option A is the correct answer to this question. Now 32 again, it's pretty simple. We need to write the IUPAC name, like name of the substance using IUPAC rules. So we just have to draw the structure, maybe the condensed structure, and then start naming. So if you try to draw the structure, you will get the structure. And let's try to number it. So this will give us the longest chain with the most number of groups. So on the second group, we have the alcohol, and on the third group, we have the ethyl. So the name will go like this: 3-ethyl pendant to all. That matches with option C. Question 33. Which pair of compounds are structural isomers? So what is a structural isomer? Structural isomer is two organic compounds having same molecular formula but different structures. So we need to check which ones will have the same molecular formula first and then check their structures. First one, propane and propene, they will have different molecular formula. Propane is C3H8, propene is C3H6, so it will not go. They are different compounds. Second one, propanol and propanone. Propanol has C3H6, so propanone again has C3H6. So, but when we draw the structures, we see that both of them are different. Oxygen is at the second position in propanone and in the first position in propanol. So obviously we have the same molecular formula but different structural formula. Option B is the correct answer to this question. You may also try the other options, but in both the options you will get different molecular formulas, indicating that they are different compounds. Now, question 34 again is probably the easiest question in this paper. What is the general formula of alkynes? We all know it's CnH2 and -2. Option C is the correct answer. Question 35. Which statement is correct about configurational isomers? So, yeah, let's start. Okay, option A is obviously the correct answer because configurational isomers can only be interconverted by breaking or reforming bonds. There is no other way you can interconvert configurational isomers. Second round, configurational isomers have different molecular formula but same structural formula. That is not correct. They have the same molecular and structural formulas. Configurational isomers are not distinct products. No, they are distinct compounds. Configurational isomers always have identical physical properties. Not really. They can have different physical properties. So from all this, option A is the correct answer to this question. But yeah, it's more of a theory question. Question 36. We have a ketone and we need to find out the product when this ketone is reduced with sodium borohydroxide, which is NaBH4. NaBH4 is a weak reducing agent and it converts a ketone into an alcohol. This is the initial compound. If you put NaBH4, you will get this compound, which is like option C, I believe. Yeah. That's the correct option to question 36. Question 37, we have to find out which attacking species is matched with its mechanism of reaction. So if we have so many species and we need to find out which attacking species will match the mechanism. OH minus. OH minus is a negative ion. Every negative ions are looking for positive centers to attack. So if they're looking for positive centers, they're called nucleophiles or nucleus lovers because in nucleus you have the positive charge. So OH minus is a nucleophile and the type of mechanism is electrophilic substitution. No, the type should be nucleophilic substitution. Cl plus. Anyone having a plus charge will be obviously looking for a negative center. If it's looking for a negative center, we can say it's negative loving or electron loving, or we can also call it as electrophile. So Cl plus should be electrophilic addition or electrophilic substitution, but this is wrong. NH4 plus again is an electrophile, but the type of mechanism is nucleophilic addition. That's given here, so it is wrong. Finally, NO plus. NO plus is also an electrophile, and the type of mechanism is given as electrophilic substitution. So yeah, this is correct. Option D is the correct answer to this question. So any negative. So just remember, any negatively charged compound or a compound containing a lone pair, they will always be nucleophiles, and every positively charged ion, that will always be an electrophile. Question 38. What is the slope of this graph? Again, pretty easy peasy question. Let's say this point is x2, y2, this point is x1, y1. Your slope would be y2 minus y1 divided by x2 minus x1. And the unit in the y-axis is mole per dm cube, that will come on top, and unit on the x-axis is seconds, it will come on bottom. So yeah, if you check the unit would be mole dm cube second inverse. And just plugging in the value of y2, y1, x2, x1, you will find that the value of the slope comes out as minus 0.0025. And we have the unit, so matching them, option A is the correct answer to question 38. Moving on to question 39, this is a mass spectrum question. So first option, molar mass is 43 gram per mole. This is wrong because molar mass is always obtained from the last peak, and the last peak is well over 80. So yeah, A is not the correct answer. Atoms have many isotopes. I don't think so because see, this atom is made of carbon, hydrogen and oxygen. Carbon, hydrogen, oxygen isotopes are not really accounted for in mass spectrums. Hydrogen, you can say hydrogen can have 3 isotopes. Carbon can also have hydrogens, but they are not much accounted for in a mass spectrum. So yeah, this will go away. The most likely bond to break is CC bond between carbon 2 and 3. Let's try to check this option. So if you draw this compound 1, 2, 3, 4, 5. So this bond, they are saying that this bond will break. Let's try to break it. If you break this bond, this side will have a molar mass of 43. This side will have a mass of 43. And we have the highest peak at 43 only. The highest peak is at 43. So obviously this bond is most likely to break in this mass spectrum analysis. So option C is the correct answer to this question. And option D, the signal with the largest mass is due to oxidation of ketone in spectrometer. This is incorrect because there is no reaction inside the spectrometer. If you want to oxidize ketone, you have to apply some really strong oxidizing agent, and they're obviously not applied inside the spectrometer. It'll break your spectrometer. Now coming to the last question. This is the last question in our question paper. So which substance has the following H1 NMR spectrum? Now if I check the signal strength, you see that these two signals are kind of at the same length. While this is a shorter signal, I can assume that these two will have a strength of 2 and this one will have a 2. The strength would be 2 in this case. So yeah, let's try to analyze each case. So there would be 3 different hydrogen environments with the ratio of 3:3:2. That is what we need to analyze in this case. So for the first propane, you have CH3, CH2, CH3. In this case, you just have only 2 hydrogen environments. These 2 hydrogens are in the same environment and this one is in a different environment. So this is 1 and this is 1, 2 environment. Option A is incorrect. In the second one, let's try to find out. In the second one, we actually have 3 hydrogen environments. This hydrogen, this and this. All of these 3 are in the different environments. But if we check the peak lengths, there would be 3 hydrogens here. So 3. There are 2 hydrogens here. So 3:2 and there is 1. That is 1. So 3:2:1. This is not what we are looking for. It has 3 hydrogen environments, but we want 3:3:2, not 3:2:1. In option C, we have CH3, CH2, CH2, COOH. In this case, we have 4 different hydrogen environments. All of the hydrogens here are different hydrogens. There is no symmetry in this compound. So we have 4 hydrogen environments, but we need just 3 hydrogen environments. So yeah, C will also be not correct. Last is ethyl ethanoate. Let's check the hydrogen environments. We have 1, 2, 3. We have 3 hydrogen environments. That's perfect. And if we check the peak length, it should be 3:2:3. 3:2:3. That's what we are looking for. 3:3:2. This is the same as 3:2:3. Option D. Yeah, this is the correct answer to this question. With this, we come to an end to the solutions of November 2021 of paper 1. I will also soon be posting for the paper 2 of November 2021. As the May attempt is coming nearer, I will also try to post solutions of the chemistry papers of other years, mainly for paper 2, because I have been getting a lot of requests to solve the paper 2. So yeah, do subscribe to my channel, do like this video, and do share it with your friends. It really helps me a lot. Thank you so much for watching this video. See you guys again soon. Thank you.